This is our last little bit of theory. Experimental probability. A six-sided dice is rolled 10 times and the following numbers come up. So even though the words experimental probability are not used in that question, you can tell because they're giving you the results of what has happened when you've done an experiment. So experimentally, experiment. Okay? So when I work out the experimental probability, I'm not just saying, oh, getting a 3 would be a 1 in 6 chance. I have to use the numbers that are up here. So I look for the 3s. There is just one of them there on the end. So my probability of getting a 3 would be equal to 1 out of 10, because there was 10 times. If you count them up over there are 10 numbers that were rolled. So 1 out of 10. What is the experimental probability of getting a 4? So now I'm going to go through here and count the 4s. 1, 2, 3, 4 of them. So using my notation, P for probability of getting a 4 is equal to 4 out of 10. But that fraction can be simplified top and bottom by dividing by 2 to get 2 over 5. So you can do that in your head. You could also type it in your calculator, the 4 over 10, and you just press the equals and it will simplify it for you if you need to. Michaela? I would like you to try to, because it's something that we like to do, but in all honesty, if you left it like that, we will still give it to you as correct. Mia? Probability. Yeah, P for probability. So the P at the front always stands for probability, and the thing that we put in the brackets is what we want the probability of. So part C. What is the experimental probability of getting an odd number? So our odd numbers are 5 is odd, 1 is odd, and 3 is odd. Everything else in there is an even number. So my P for probability, and in the brackets I'm going to write the word odd, for getting an odd number, is going to be equal to 3 out of my 10. Does that fraction simplify? Nope, so we're done. Question 2. When playing with a spinner with the numbers 1 to 4 on it, the following numbers come up. So here is a new set of results for us to do our probabilities from. Part A. What is the experimental probability of getting a 3? Can you open the door, please? So there is 1, 2, 3, 4 of them. So the probability of getting a 3 this time is 4 out of 10. So that was the exact same question, but because I have different data this time, I'm getting a different result to example number 1. Does that fraction simplify? Yes, let's divide top and bottom by 2 to get 2 over 5. Question B. What is the experimental probability of getting an even number? So 4 is even, another 4 is even, 2 is even. So I've highlighted all of the even ones, and the probability of even is going to be equal to, there was 3 of them out of the 10 numbers. That doesn't simplify, so that's done. Question C. Based on this experiment, how many times would you expect to get a 3 if you spin 1,000 times? Now, I have circled quite a few times that word expect. When you see that in a question, you want to multiply the probability of getting whatever it is you're asking. So in this case, it's the probability of spinning a 3. You want to multiply that probability by the number of times that you do the experiment. That's how you find, it's called an expected value. So my probability of getting a 3, that was this one, same as this up here. It was 4 out of 10. I multiply my probability by 1,000 because we're going to do this 1,000 times. Okay, so that's a good thing to put on a study sheet. Good question. If you see that word expect, it's the probability times the number of trials. So you can type that in your calculator. You can go 4 over 10 times by 1,000 equals, and it gives me 400. Oh, it is called expected value. Okay, so you'll see the word expect in the question. How many times would you expect it to happen?